Okie dokie, that's the time for that one. 5 minutes, wasn't it? So let's have a look. So Kim, this time, if you could please read the question to me. Hang on, George is making too much noise. Hurry up, George, go on. All the physics is making it too hot, is it? No problem, no problem. Go ahead, Kim. Give me the info now. A what suspended? A meter stick?
Yeah.
Yeah, okay.
From 2 threads.
Okie dokie.
One at each end.
One at each end, okay.
These threads are tied together and supported as shown in the diagram.
Oh, is that the one that looks like this?
Yeah.
Like that? Okay, what else now? Oh, it's the meter. So I should draw my meter stick like this? The other way, okay. Yeah, show us the picture. I see. This is here, this is here, this is here, and then it's like a hook here. And you have 60, 30, 1 Newton. Okay. So this here is 1 Newton. This here is T1. This here is T2. Are you told anything else? You're told the angles. Are you not told the weight of this meter stick? No, it obviously has a weight. And this angle here is 60 degrees, and this angle here is 30 degrees, and right here in the middle is its mystery weight, which we don't know, and this distance here is 0.5 of a meter, and this distance here is 0.5 of a meter. Thank you. What's the first thing we're asked for? What do we want first? The weight has to be in the middle of the meter stick. See, the clue was in the name. Meter stick. Did you all miss that? You all missed it. Wow.
I missed the 1 Newton as well.
Man. That's not going to help you solve it. Remember what Connell taught you? Connell's your English teacher, isn't he?
Yeah.
He taught you this, didn't he? He didn't teach you this in English. That's it. Alright, so what did they want in part A? Kim, what did they want in part A?
Sketch this arrangement and mark clearly with an X the center of gravity of the meter ring.
Oh. X. Okay. How many marks for that? 1. Seems fair. And the next part?
And the magnitudes of the tension forces in the 2 threads, T1 and T2.
Mm-hmm. 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 This is a very interesting question because it's a lot easier than you think. They're always the best questions, the one that looks really hard but actually are not that hard. How many marks is this? 4 marks, yeah. So here there's like a hook, okay? There's a thing that it's hooked on, whatever it is, okay? Imagine for the moment, use your imagination, you all have imagination, you are the hook. You are the hook. What forces are pulling on you? How many? 2. Is it 2? Is it 1? Or maybe it's 3. See, if you were here, you would have one thing pulling you up, wouldn't you? And you'd have 2 things pulling you down. Now you see, you think the weight, but it's not. because only the strings are connected to you. Now the weight obviously affects the T1 and the T2, but if you were here, if your job was to be the hook here, you would feel exactly 3 forces on you. This is what your world would look like. Here you are. Your job is you're now a hook. Congratulations. You'll have 1 force pulling you up here of 1 Newton. And then, according to Newton's law, you'll have 2 other forces pulling you here of T1 and T2. You know, because this T1 is pulling the stick up. So likewise, there's a T1 pulling down on the hook. Now, have you seen this picture before? In which lesson have you seen this? Yeah, very good. Now we just need to work out the angles. So this angle here, how much is that? 90, good. And this angle here is 120. Because you see you have 60 here, and that's 180. And how much is this one here? 150. Okay. So do you remember Lamy said T1 over sine 150 equals T2 over sine 120 equals 1 Newton. So by rearranging this, oh well look, it's even simpler. If these are supposed to equal 1, then it means on the top and the bottom of these fractions should be the same. Because that's the only way you can get a fraction equal to 1. So I'm finished. T1 is sine 150 and T2 is sine 120. So what's sine 150? Now that sound you made, is that that's a, oh I got it right, or that's a, oh no.
I got it right.
But
I used like
a much harder way.
resolve.
Yeah, you resolved it, yes. Or do you use turning force?
No.
No, okay. What's sine 150?
So we have to follow the particular in the one, or can we use
Well, just 1 sec, I get to that. What's sine 150?
0.5.
0.5 newtons, and sine 120?
0.866.
0.866 newtons.
I got 0.5.
Yeah, good. Now, there's many approaches you can take. We'll check the marking scheme now in a moment. Matt is very sad because he realised the way he did it, although it gave him the same answer, was longer.
No.
No.
It's 1 times cos 60, 1 times cos 30.
Okay.
Yes, it's just cosine 60 and cosine 30.
Okay. By resolving?
Yeah.
Okay, okay. That's fine. How did they do it in the marking scheme? They didn't use Lamy's theorem? Did they? This is A.
Resolve.
Resolve! That's the Matt way to do it.
Yeah,
I want the Lamy way to do it. Okay. Well, what matters most is which way you prefer.
So even as long as we get it correct.
Yeah. Whoever writes the exam doesn't like using Lamy. They prefer to resolve, I've noticed. Did it take you much longer to resolve it? To do it this way?
I just guess the method.
You guessed the method.
Because it's 90 degrees, so right.
Okay. It works, I suppose. Okay. Anything else with this? No? Just before you go, I'm just curious. Is A6 couldn't possibly be another mechanics question, could it?
Yes.
No. Another mechanics one.
Yeah.
When's the first non-mechanics question?
8.
8. Okay. I'm going to give you a little homework to do. When's our next class? Tomorrow? Right. Tomorrow, yeah. So I want you to do, now you must do this as a homework. I want you to finish section A, because then in the next class I'll just do all the answers straight away. Okay, so can you all finish section A for homework, please? Right, we'll leave it there. So